Hello guys and welcome back to my channel. Today we are going to discuss about data preparation phases to model the data. Now what are data preparation phases so that we can model a data. Now this presentation will explore the process of preparing data for machine learning, focusing on techniques like partitioning, balancing and building decision trees. The data preparation phase is crucial for building accurate and reliable machine learning models. By ensuring data equalities, consistencies, and relevance, we can significantly improve model performance and reduce the risk of bias. Now, moving to the next slide, partitioning the data in Python. There are three ways in which we can partition the data. First, training set. Used to train the model, teaching it to recognize pattern and relationship in data. For example, if in a customer prediction project, we will use a training set of 70% of the customer data containing features like age, purchase history, and engagement metrics. Validation set used to tune hyperparameters and evaluate the model performance during training. We will use a validation set of 15% of the customer's data, which will use to adjust model parameters like the depth of the decision tree and the number of trees in a random forest. Test set used to elevate the model's final performance on unseen data, simulating real world conditions. In our example, we will use the remaining 15% of the customer's data that will be our test set, evaluating how accurately the model predicts customer churn based on their features. Now, how we can balance the training data set in Python? First, imbalanced data. What is an imbalanced data? One class has a significantly large number of samples than others, which can lead to biased models. Balancing techniques, oversampling, undersampling, and synthetic data generation can help create a balanced dataset. Improved model performance. Balanced data leads to more accurate and reliable predictions by reducing bias and improving generalization. Building classification and regression tree using Python. How we can build a card tree in Python. Now, first step, classification and regression trees, aka SKART. A popular decision tree algorithm used for both classification and regression means this tree helps performs classification and regression simultaneously. Recursive partition. Card builds the tree by recursively splitting the data into smaller subsets based on features. Means the data is divided into subsets and then that subset is divided into further subsets. Third, Gini impurity or entropy. The algorithm uses metrics like Gini impurity or entropy to determine the best split at each node. Now, here, as you can see in the image, there is a decision which has two parts. Now, these subparts have further subparts where this is ended, and here it has more further subparts. Now, building C5.0 decision tree. Here is a card and C.50 column. Now, uses Gini impurity or entropy means use information gained for splitting. Punning based on cost complexity means use a more sophisticated punning method. More widely used for regression, more widely used for classification. So here are the differences that a card tree or a C.50 tree have. Now, building random forests in Python. Assemble learning. Random forests combine multiple decision trees to improve accuracy and overfitting, bagging and random subspaces. Each tree is trained on a random subset of the data features, introducing diversity. Averaging predictions. The final prediction is made by averaging the predictions of all individual trees, reducing variances. Now, evaluating model performance, accuracy, precision, recall, F1 score. Now, what are all that? Accuracy, the proportion of correct classified instances. Precision, the proportion of true positive among all predictive positives. Recall, the proportion of true positives among all actual positives. F1 score, the harmonic mean of precision and recall, balancing both matrices. Now, conclusion. By carefully preparing data, selecting appropriate algorithms, and evaluating model performances, we can build accurate and reliable machine learning models that deliver valuable insight and prediction. So, this is all for today. We will meet in the next lecture. For that, goodbye, take care.